guys understand it from a layman perspective. That imagine you run a business and your business have many departments. What you do normally is that, let's say you are running a standard business where you have a shelf, where you have um where you have, let's say you run a company. Okay, so let me describe it in a broader sense. So let's imagine you have a company and your company is situated in a cage. So let's imagine that this is the house where your company is. Now, and let's imagine that compound is called the server name. So let's say this is the door to this compound. Okay, so it means that before you get into your database, you must first of all open up the gates to your office. Okay, so you enter into the compound. Now, in that compound, it's possible to have many buildings. So let's say you have building A, building B, and building C. So let's imagine that that different building is a database. Okay, so database, a server can have many databases. Okay, I don't know that you guys are understanding the logic here. So it's possible. So you have a big compound. Let's call it a server. In that server, it's possible for you to have different buildings, and let's imagine that those buildings are databases. Now, this is building A, B, and let me make this building C a very, very big one. Building C. Okay. Now, imagine that we are interested in going into building C. So I get into the compound. These are different databases, like different houses, but I'm interested in getting into this house, building C. So this is a database name. Okay. Now, inside of that building C, there are different offices inside. Okay. Let's call this office Y and Z. Okay. So let's imagine that in that of building C, which is database, you have different schema name. Okay. So let's imagine this is building. Let me remake this so you guys can understand it. This is building C, and you have one very big. Let's call this X. Good. Now, these are so all these little rooms in this building C, let's call it a schema name. Okay. So schema name is like some little rooms inside of the building. Now, in that particular room X, it's also possible to have what we call the object name. So we can have inside of that room, you can have a kitchen, a storehouse, and a bedroom. Just give it an example here. So let's call this 1, 2, 3. So so this object's name is now those little rooms in this place. Okay. So if I want to go into my bedroom, right, in this building, the journey will start with the building is in Ikeja. When I want to come to this C3. The database name is C. So this is Ikeja where your office is. So I'm going to get into this particular spot. I will need to follow through the address. Ikeja C. Schema name is X. So the name of this entire schema is X. And the object is number 3. So this is the address that leads us to this particular bedroom here. So what is a schema? Let me explain what a schema is. So a schema is a namespace where database object is. So let's cut this server name. Let's assume we know the server name, we know the database. All right. Now, from this point to this point, let's say this is the schema, right? HRO, right? The object names are the little rooms inside of that schema. So let me explain it in SQL terms. So in SQL term, what this means is simple. Inside of every schema, there are object names. So if you run a company, like I tried to describe the first time, and you have a place where you keep people's name, staff's name, a place where you talk about departments, where you have the department names, you have the place in the HRO that you have salaries, right? So these are under one HRO, but you have inside of that HRO, that house, right? You have little rooms, and that little rooms, I will call them objects. So these are really tables, right? Like tables in database sense. So let me go also to this. So this is exactly the schema that you guys have been querying since you started your journey. Please, if you have any question, you can ask, please. But if you don't have any question, please try to mute yourself. Right. Okay. So if you guys look carefully on my screen, you see this is if for those who have been doing their work, really, they will see something clearly. They will see schemas. In this database, you have sales schema, purchasing schema, person schema, production. Please, who is muted, please? Who's unmuted, please? Can you mute yourself so that we don't get distraction from anybody? And please, everybody write on the group that the class is ongoing so that we have more people join the session. Just write on the chats telling your colleagues that the class is on. Please join. Okay, good. All right, so you could see that in this particular business, it has many schemas. Like it has 5 schemas typically. So what are schemas used to do? Schemas are used to keep information, related information together. So everybody who has ever worked here, we know that if a business has a database and the business has a department called human resources, what will happen is that in that human resources department, you will have somebody saying something. Please don't distract us, please. If you're not muted, please mute yourself, except you want to ask a question. Good. Okay. If you want to ask a question, please, you can unmute yourself and ask. All right. So you could see that, let's take one of the schemas called human resources schema. Now, that's a schema, like a namespace, like a house, where information, related information. Now, notice that in the human resources schema, you will notice the kind of tables. Now, when we use the word object name is sometimes interchangeably called tables, right? So don't mix it up. Don't be confused because you hear object name and later you hear table. Okay? So object names or tables. Okay? So these are tables in the human resources. So you could see that they are related to each other. 1, 2, 3, 4, 5, 6, 7. Okay? you will notice, if we scroll it down a little bit, you will notice the kind of tables that are there. They are usually very related tables. So you look at job candidates, right? Every one of you, if you've applied for a job, so let me tell you what the designer of this database intended. It believes that everybody who comes into this business will apply for a job. And if you submit your resume, you are supposed to get a candidate ID to come and write an exam. Okay? Right. So it believes that when you are now qualified and you are successful, you move from being a job candidate to becoming an employee. So if you pass the exam, this is related to this, and then you have this information. So you could see information about the employee ID, the national ID, those basic information that they give to you when that they ask of you when you are being employed. Okay, so let's imagine you are successful. The company now takes a lot of information, your birth dates, your marital status, your gender, your hire date, and so many other information you might not even be aware of that will be generated under the employee table. Now, everybody who is employed as a department, you're posted to a department. Okay, you have a start date, you have a department ID, you have an employee ID. You could see how these tables look like. Everybody who's employed in this particular business has a shift. Okay, name, start time, end time. Everybody in this job is paid a salary, and then everybody that works here has. We want to know your addresses. So the designer of this database created a schema such that that schema will contain information related to human resource information. That doesn't mean that schema cannot relate to another schema, but that's a question for another time. We'll talk about it later. So this particular stuff is what we call schema. And inside of a schema, we have what we call objects, or what we refer to as tables. Okay. So far, does anybody have any question, or you want to clarify something? You can unmute yourself. If you have any question, unmute yourself in 30 seconds so that we can continue. All right. So since there's no question, we'll proceed. Good. Now, everybody now understand what this is. So for us to know the address, like we use the KJAR and the address, for us to know the address of a particular table, what
Hello,
this is
sir.
explaining.
I'm asking a
Yeah,
question.
go on with your question.
Okay, sir. My question is this schema. I'm so sorry. Like, can you give an example? Maybe if you give an example, I can actually understand what we are talking about. Because I'm still kind of a little bit lost. But if you can give an example, then maybe I can relate well with your explanation so far. Can
What
you
do
give
you
us an
mean by
example
example?
in
What
like
kind of
of
example
this
are you
schema?
asking? Huh?
Like in the table you gave us, like the information you provided for us in that SQL. Can you give me an example of a particular thing that is a schema there?
Yeah, I'll explain that to you. But do you understand? First of all, hold on. Who is speaking, please?
This is Zainab.
Okay, so Zainab,
Yes, sir.
you get to understand what we are doing, but the information I'm giving to you now, take it in first. Okay?
Okay, sir.
Forget about whatever you know before, what is confusing you. Take it in first. Okay?
All right, sir.
Forget
All right,
about
sir.
what you have struggled with. Just take the information in. I've given you two examples already. One is that I try to describe a house, okay, where there are
Okay.
many buildings in it. And I said that that compound where that house is, let's call it a server. And inside of that
Okay, sir.
house, you have three buildings, okay? And inside of those
Yes, sir.
buildings, you have rooms, okay? And
Yes, sir.
inside of those rooms, you have inside of those rooms, inside of that building, you have rooms. Okay, so I've described
Yes,
it in
sir.
that sense. Okay, so I then went further to show you that talking about what you already learned, you see these things live shortly. Just I then went ahead to explain to you that this particular picture that you all have here is the example of your database that you have been querying since, but you don't know. Okay, all the
Okay, sir.
schema that you've been querying since human resources and employee. This is a schematic view of how it looks like when it's not in the database. This is like a picture. Okay, hearing me?
Yes, sir.
Good.
Yes, sir. I can hear you, sir.
Okay, like a
I think
picture
I'm
of all
getting
the
it now.
yeah, it's like a picture of all the database you have been querying with many tables inside of it. So you can see,
And colons.
you can go on mute, but you can see schema for sales, schemas for purchasing, schema for person, schema for production, and schemas for human resources that employee. Okay. Now, if for example, you want to come to this is schema, human resources. If you want to come to this particular object inside of the human resources, you must follow through a process which is called an address. So you could see, let's say this is the HRO, is the name of the schema, right? For you to come to this table inside of the schema, you must be following an address called HRO dot staff. So most of the things you have done so far, where you were saying select the address of that place table you want to select or you want to query is defined by the name of the schema and the object name. Okay. So Zainab, have you ever queried anything since you started to learn?
So
Hello, hello Zainab,
now.
have you ever queried
Yes,
anything?
sir. Yes,
Uh-huh.
those exercises under each modules, I practice them.
Okay, so if you've been practicing them, those times you do select
Yes, sir. Then
from,
form.
you do from,
Yes, sir.
you do human resources dot employee.
Yes, sir.
Have you not done something like this?
Yes, sir, I've done that. That's why when you
So,
explained, I said, yes,
yeah, so what you actually were doing is that you were locating the name of the schema, which is the name of the schema, dot the name of the object, which is employee. You understand it now?
all right, sir. Yes, sir.
So
I got you now.
that's what you have been doing, all right? And that's what you can see in this
Yes,
picture.
sir.
Human resources dot
Yes, sir.
employee.
Yes, sir.
You want to get that location, you do human resources dot employee. That locates you to this particular object. Okay, it's like an address to a
Yes, sir.
place. You pinpoint something. So I haven't seen this schema. Okay, let me show you other things. Okay, so some of you talked about the dictionary. Okay, now the dictionary for every database that you want to query is that normally they have a dictionary. A dictionary is is one of the most important thing to understand the table. So just imagine that any one of you has a database and you just employed me and I'm a data analyst. How do you think I'll be able to know about your human resources, your sales department, your this department? Traditionally, a normal company or a standard company is supposed to have a dictionary that explains what every information in the database is. So you're not just querying randomly. Okay, so you understand, oh, I want to get this information, where to get it from. Some of the things that everybody who I've taught usually at the first time is that, okay, if I'm asked a question, how do I know the table to go pick it up from? Now, it comes in two ways. You either ask questions or you're given a dictionary to see it. So most of you, like we've just said now, every um normal any standard database will have schemas. Now you could see the schemas here. You could see the schemas that exist here. So you could see human resources. And these are all the tables under human resources. Human resources is the name of a schema. And these are the tables. Human resources, the department, human resources, the employee. So department is a table, employee is a table, employee department history is a table, job candidate, shift, employee history. So you can even see it in this picture. 1, 2, 3, 4, 5, 6, 7, right? So you could see human resources as a schema has some tables inside of it. Good. Okay. Now forget about what this view. Okay. Just let's stay with the human resources. So you could see another table called production or product table. Okay. All the tables under the products table. So in this particular business, I will explain to you what this business does so that you guys can know what you're querying. It's important to understand the context of the business so that it's easy in your mind. Because just querying doesn't help you. It's for you to understand what you're querying and why you're querying what you're querying. There's another table called products. Now, this particular company does production of bicycles, equipment. Okay, I'm going to show you. And under the product, they have many tables that stores information about the product. You all know that if you manufacture a product, you do things like the products will have product categories, product product description, product model. You could see the production has many tables under it. So let's see it in this picture. Look at this production. You can see many tables under production. Okay, that shows you that, oh, this business is into production of bicycles. So there's many tables to store very small information about products. And I'll tell you why they store it into multiple tables. The reason we store it into multiple tables is for them to have relationship. I'll go back to the explanation of that relationship later. So you can see production has many tables because they're storing many information that cannot be in one table. They're breaking it down logically so that they can all relate to themselves to become one thing. So you can see the relationship that exists. So you can see the dictionary has products and production. So you could see another one called manufacturing, production bill, production, the transaction history. See another table called purchasing. See the tables under the purchasing. All right. All right. So there are many tables. You could see sales. See many tables under sales. Okay. So why am I showing you these guys, these things? It's so that you can understand what we're doing. So let's understand what this business does. And I know all of you are used to the human resources that employee. So we're going to use that table as the first example. So the dictionary went further to explain some things, primary key and some other key. Don't worry about this yet. We'll explain it further because I gave you guys some things to read about, but we'll come back to it. Right. So now look at what this business does. So let me explain it. So this is a sample. It's a fictitious database that is not a real business. So the AdventureWorks database supports standard online transaction process scenario for a fictitious bicycle manufacturer. So you just try to create a fictitious bicycle manufacturer. The scenario includes they involve in manufacturing, they involve in sales, they purchase from vendors outside. So there sometimes they don't have something internally they manufacture, but they also purchase from outside. All right. So they do a lot of invoicing. They do product management, which is arranging them in a shelf, knowing the position they are. They also have customers, so they do contact management and they also pay staffs. So it is based on the activities that they do that then define the kind of table that they are involved or the person who designed the database would design. So they will tell, so if I am asked to do a database for your university, your department in school, the first thing I would do is I will asking for question, and based on the question I've asked, I will then create a database based on those understanding. So also for this business, because we now understand the kind of things they do, a database was then created for them. Okay, so they do human resource management and so on. So let's go to the human resource management table, schema, so that you guys can understand all the things you have been querying. Every of you must have queried that before. So let's go to the human resources. So it is a hyperlink. So you can click on the human resources, click on it to go there. So this is the table, some tables that are related from other tables and how it is related. Okay, so some tables relate to it from another schema. So this is just trying to show you relationships. But if you go to the table, it will then describe to you what the table is about. So the table containing the department within the Adventure Works company. So it shows you departments, salaries, departments, and a lot of things. So this is the first table that is human resources schema department. So this is the address. This is the schema name. Then this is the object name. Or somebody else can call it the schema name and the table. See that? All right. So what this database dictionary does for you is that it helps you understand what every information on the table means. Okay. So let's go to another one that is very familiar. Human resources employee. So sometimes, so you could see human resources employee table, employee information such as salary, department, and title. So let's imagine this. This is the one you guys, you know, so the database designer created business and ID. Everybody in the business has an ID, and it just says that it's in integers. Of course, I gave you an assignment to read about data types, and it then defines what it's about. National ID. If we are employed today, they will ask us for our NIN. So the designer of the database said, okay, because this information is unique, I need that information. So these are the things that were collected from staffs. Login ID. So somebody can see organizational level. He might not know what it means until it comes to the dictionary to look at what it means in the dictionary. Somebody can see salary flag. Although you query the database, sometimes they might be asking you, tell me the staffs that receive money hourly. So you could see something written salary flag. You could see 0 hourly, not exempt from collective bargaining, 1 equal to salary. So what do I mean by that? So let me show you what I mean by that. So let me go and do a query. All right. So let me do a query. All right. So let's say select from. Right. So for those people who ask me the question, where is this thing in the database? So let me show you. Look at the database. Right. In my own case, I have more than one database. So I have Adventure Works and Adventure Works DW. I have another database that I created myself. So you can see it's possible to have more than one database, just like what I described, that if you enter a building where there's a server, it's possible to have many houses or buildings inside of it. So in this our case, we're entering into this particular building. Okay, let me open it up. Okay, so you could see database dictionary tables. So if I open up this table, you see a lot of tables. So you could see all the schemas that we are talking about on this. You see right here in the picture or in the dictionary, you could see them here like this. Human resources department, human resources employee, human resources employee department history, human resources employee pay history. So you could see this first few um, uh, tables or what you can also call objects, are exactly what you can see here in this schema, under human resources schema and this. So if somebody wants to know anything about human resources of the employee, this is what you do simply. You open it up, okay, from, of course, most of you must have queried, so I will normally drag and drop. I could say select asterisk. Of course, you guys know what asterisk means. Asterisk means you want to select all the tables. Good. And you can now want to select all the columns in that particular table, and I execute. So you guys can see the way it looks. Now, if somebody asks you from here, please, what is the meaning of salary flag? So you could see 1, you could see 0. You could see 1, you could see 0. So sometimes you might not clearly understand what these codings mean, except you look at the dictionary to explain to you what does 0 and 1 mean. So right here in the dictionary is telling you that hourly, that job classification 0 means hourly, not exempt from collective bargaining. So there are staffs that they pay hourly, and there are some staffs that are paid monthly, they pay salaried, and they are exempt from collective bargaining. So without this dictionary, even if I can query, I might not be able to understand what things mean. All right, so you can see hire dates. If you're confused about what it means, you can go on to the dictionary to see what hire date means, employee hire on this date. What vacation hour mean? Number of available vacation hours. And if you go check it there, vacation hour, you will see 99 hours, 1 hour, and the rest. Okay, so without a dictionary, there's some things that you are limited to understand. Any questions so far? Does this make it clear from you guys? You can unmute yourself and speak now. Can you guys hear me?
Yes, please.
Yes,
Yes, I
sir.
can hear
I
you.
hear you, sir.
Yes, I can hear you.
Good, 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 good. All right. So is there anybody who wants some clarification? Does this make your understanding better?
Yes, sir. Yes, sir.
Yes, it
I
does.
understand
It
better now.
does. Thank you.
Yes, sir.
Good. All right. So let's go over to the next thing. So I've explained the dictionary for you guys now in practical sense, so you guys can see it, right? And you guys must have started to use SQL statement types, okay? So most of you have done select. Select is data manipulation language, but let me explain to you in a big sense. So we usually will have the data query language, which most of you are doing right now, SQL, right? Query. But there are people who created this database that we are using, right? And the dictionary. So sometimes you might want to create your own table. You want to put new information in database. The people who have expertise is those people who have learned data modification language. You could see what we are just doing here is to query. We're not really modifying. So there's sometimes when somebody want to create a table, want to remove a number. So the person then learns further using the statement type called the data modification language, where they can insert a new table or delete, update, and delete. For those people, for this amazing database that you guys are seeing that somebody that was created, it was somebody who thought through, but and then decided to create the tables. Like you can see on my own database now, you could see that I was the one who created this myself. Okay, there's no database online or anywhere that is called Scholars DNA. I created these tables myself. Okay, You can see the tables that I created, business.guest, business.hotel, and so on. Okay, so that knowledge of creating databases is what we call the data definition language. I'm not telling you to learn this now, anyways, but I'm just showing you what it is. Okay, data control language, data administration, and data transaction control. So there are many types of SQL data type, but we are very largely more interested in number 1 and number 2. But of course, for those who want to learn advanced stuff beyond this class, beyond querying, um, you could learn this. But for those who are data scientists, data analysts, you just might really need these first 3. But we are only in the course of this program only learning the query. All right, but you might need this and this, but this is the major one that you really need typically, because most times people don't employ you to come and create databases for them. But yes, if there's enough time and I see that you guys are energetic, we can learn others. But for now, the data query language is what you guys are interested in doing. So module 2 was you guys were asked to go learn to read up some stuff, right? So what you guys have been doing so far was to do select from, where, group by, having, and order by. Good. So let me ask you guys a question. Does anybody understand? Is there anything that you want me to clarify under the select statement? Because I think I've done it a lot in the class, in the recording. If you guys want a specific question that I should clarify, you can bring it up now. And that would be module 3. Somebody asked a question about module 3 earlier. Good. So since there's no question, I believe that everybody understood that during the recording process, how to query data using select from where, select from, group by, select from, having, and select, and using the order by. Good. Okay. So we did a lot of these selects, and I think everybody understands it from the recording. Makes the life easy. Good. All right. Now, this is the part that I have come to this class to introduce, is that, have you all noticed that all the tables that you've been querying one single table? Please, you can unmute yourself and speak to me now. Did you notice that you've been querying only one table? Like human resources and employee, did you notice that?
Yes, sir.
Okay. Anybody else notice that? Anybody else notice that? You guys should speak to me. Didn't you guys watch this recording? You guys are not doing as if you watched the recording.
Yes, sir.
Yes, sir. Yes.
Zainab, are you there? Are you
Yes,
with me?
sir. I think we still query the person,
I
not
can hear you,
just
sir.
human resource.
Yeah, I know you all queried. You can mute yourself now, Zainab. You all queried.
All right,
What I
sir.
asked is that you guys notice that you've been querying single tables. That's, you query human resources, that employee, person, address, production. You guys
What you
notice that
meant
it's only one specific table that you're querying. Okay.
that we are not
Yes,
joining
sir.
tables, right?
Yes, you were not. You were only asking a question, right? You were not. You were only querying one table. We were not joining them. Good. So let me explain to you what a join is. So the next, I'm just only going to introduce this concept because this class is supposed to end, and then I'll teach it practically in our next time we meet. We're going to meet shortly so that we can wrap up this SQL. It needs to wrap up in January. Okay, so we're going to meet in the course of the week, maybe on Wednesday or thereabout, or on Tuesday, but we all should meet. So retrieving data from multiple tables. So now let's learn the concept. This model focuses on joining and retrieving data from multiple relational tables. So we're going to learn the concept of SQL join, the different type of joins, how to combine multiple tables together, the effect of improperly joining table, and renaming table in a querying using an alias. Okay. Now, if you guys really followed the recording very well, you will notice something right here. So let me ask you guys need to unmute yourself and answer this question. Give me a moment. Let me go straight. Good. All right. So can somebody tell me what product did Dan Drayton buy? Anybody can unmute yourself. Tell me what product this person called Dan Drayton purchased. Can you guys tell me what Dan Drayton purchased? Anybody tell me what Dan Drayton purchased? Hello?
Hello, sir.
Somebody tell me what Dan Drayton purchased. Dan Drayton.
Hello, sir.
Thingy
He
sir.
purchased bulb.
You purchased what?
Thingy Bob.
So how did you do it? How did you do it? How did you know
What you do
that?
is to follow. You follow the primary key and then the secondary key.
So what you did was to do this, but he purchased this is his identity, C1 and C1. C1. So how did you pick
Or just
Tingy Bob?
Wingard and Tinsy Bob.
All right. So how you did it was, if you were going to look at the first item he purchased on the 1st of January, your journey will be this, okay, and connected to this, and this connected to this, and this connected to this, and this connected to this. Is that what you did?
Yes.
Yes, sir.
Yes.
Good, good. So the language to bring to what join will do for us is we want to learn the language such that we could relate multiple tables together to understand a thing. Okay, we want to make the tables speak to each other to produce a desired result. Okay, so you can see from this schema that there's a lot of tables that are scattered everywhere. But notice something. Notice something from, I want somebody to notice something about this employee table. Can anybody tell me what is missing here?
What is common, sir?
Say that again.
What is common in the employee table?
No, not what is common. What is missing? If, for example, I tell you about an employee and the employee has national ID, contact ID, what do you think should have been collected from the employee that is not listed here?
Name.
Good. There's no name for the employee, and somebody will confuse, okay, how do I know this employee? Now, the designer of this database really did what we call normalization. Don't worry, we'll explain that later. Don't worry about it. So what happened was that these tables were broken down such that the name of the person is not here, but it is there. If only you can relate this employee table to this person schema, to this contact. So all the while you've been querying human resources employee, you notice that the name did not appear. Until you relate this table to this table, to get the name of the person, if you query all of this table, you get some truth. But if they want you to know the name of the staff, until you speak, you allow these two tables speak through the concept of what we call join, you will not be able to get extra information about that person. I believe you all get that. You get that?
Yes, sir.
sir.
Yes, yes.
Good.
Yes, sir.
So that's the entire concept of join. But of course, I will. So that's what the concept of join. So let me go back to the module. Good. All right. Sorry, need to go back there quickly. Okay. So you could see that relational databases, they're called relational database because they are broken down into bits such that they can be related. They're broken down into logical groups so that they can be related to each other. Good. Data is distributed across multiple logical tables. So you could see that based on the example, for me to know what Dan Jones, where Dan Jones lives, I need to relate this to this through what we call the primary key. And sometimes they can call this foreign key. So every table has a unique key or a unique column called the primary key. It is the basis for the relationship between two tables. So if you look carefully on your database, you will notice that every time that so we're using the human resources table as the example, as a guinea pig, you will notice right here that there's a black key here. And you could see it is called business entity ID. You could see it is named primary key. You could also see that it is named foreign key. What it means is that it is also a foreign key to another table. It's primary key, but it's also a foreign key. It is written in integer. So you guys already in module 2, I told you guys to go and read a section of a text that talked about data types. If you've not done so, please go and do it, because you might not be able to understand things further if you don't do this and not know. So let me explain to you what this means. Now, just imagine that you all have a bank account, right? Your bank account number, let's say you have a bank account with GT Bank, and your account number is 101. Another person's account is 102. Do you know that in that bank that you're the only one that has this bank account number? Do you know that?
Yes.
Good. Now, what it means is that nobody else, it's only unique to you. Nobody else can have the bank account number 101. So it's a primary key, but it's also very unique. So if, for example, that this is the table in your bank where this is your account number, your name, just using this as an example, all right, and let's say your address. And this is your bank account 101. Nobody. So why it is called primary key is that you can never see somebody else who have a bank account 101, because there'll be a conflict between these two people. So that's why we say it is a primary key and it is unique. No two persons can have it. So let's imagine somebody's name is Linda, James, Tony. So let's call this middle name. And let's call this last name. So you could have, let's call this middle name, and last name. So you could have Linda, Tony. You could have Linda, James, Kelly, and Tony, Abraham. You could have his middle name is Ben. Now, what this is saying, so let me explain this business entity. So let's imagine that this business entity ID is the account number here. So what we are saying that it is primary key. Primary key means that it must be unique. So this situation can never happen where you have 101 twice. It's an integer. So what this means is that you can never have a number 1.2. So that's why it's an integer. Okay, you have 1, 2, 3, 4, 5. So you guys learned about the data types. Please spend time to read it if you've not. And it's also saying that it is not null. So what it means is that that particular primary key column cannot be null. It means that you can never have this situation where you have 101 Linda Tony, 102 James Kelly, and then not have a number here and you have Tony Abraham. This is never going to be acceptable because it cannot be null. So you can see the word not null. It means that it can never accept any entry if this primary key is null. So we're saying is not null. So it can never be like this because it must collect and information must be here. Unique ID must be here before you can have name, middle name, and the rest. Right. I believe you guys understand this.
Yes, sir.
Yes, sir.
Good. All right. So sometimes when you see something like not null, you could see null. So anytime you see null, it means that there can be null in that particular. For example, if I want to do a table that has a middle name, not everybody has a middle name. So I cannot write when I'm creating a middle name column, when I'm designing it originally, I cannot write not null because some people exist that don't have a middle name. So if you do that, you don't be able to have information because some people can come to you and say, well, I don't have a middle name. And if you've designed it that it must have a middle name, that means you cannot take that entry. So you could see sometimes you see null. So it's possible to have a null. So in this particular business, they said there's nobody who will be written in the database that will not have a birth date. Everybody must have a marital status, not null. Everybody must have a gender. So you cannot have a blank gender. Okay. Everybody must have a higher date. So all these things that you see not null means that it is compulsory. But ultimately, anyone you see a black key and the primary key is the primary key for that table that is the basis for relating that table to another table. You only use the primary key and the foreign key to relate two tables together. So in this little example that you have right here, we'll assume okay, so we'll assume that this is the primary key and we'll assume that this is the foreign key. All right, and we'll assume that this can be the primary key of this particular table, and this is this can be a primary key as well be a foreign key itself. right? So it's a primary key to this, but it's a foreign key to this, but it's a primary key to something else. To itself. It's a primary key to itself, but it's a foreign key to this particular table. Good. So the basis for the relationship of Dan Jones, okay, is this related to this, related to this, related to this, and then we can know that he purchased a face cap in 18 pounds. So the language or the understanding to be able to, for tables to speak to each other is on the basis of the concept of join. All right, so join clause is used to combine rows from two or more tables based on a matching criteria, usually based on the primary foreign key relationships, right? So like what I've just explained just now. It helps to think of the table as a set of Venn diagram. Most of you who did GS3 or who did secondary school maths must have come in contact with what we call a Venn diagram. A lot of people usually love this particular course because it has graphics in it and it's self-explanatory. So we'll think about join in terms of a Venn diagram, right? But so far, is there any question from anybody?
Yes, sir.
No.
No, sir.
Did you
That's
say
all, sir.
no? Good. All right.
Yes.
If you have a question, go ahead. If you don't, I'll go ahead.
There's a question, sir.
Yeah, go on with your
Yes, sir.
question.
Yeah.
Go on with your
My
question.
question is that. Yeah, my question is, I want to know what's the difference between an Excel and SQL.
What is the
Yes, sir.
difference? What is the difference?
Yeah, between an Excel and an SQL.
Okay, so have you taken the Excel class at all?
Yes.
Okay. So what did you do in the Excel? What did you do in Excel? Can you remember?
Uh, we did a lot like formatting, um, uh, some statistics and basically analysis also.
Okay.
If
So
I'm
what are
correct,
you
analysis.
have you queried anything in this SQL?
I've also done SQL.
Good.
Like I've done the section in SQL.
Okay. So you're asking what is the difference?
Yeah, because it's also the same thing, analyzing the data also.
You've not analyzed any
Hello?
data in SQL. You've not analyzed any data in SQL. We're just learning how to query it out. So let me explain to you. I'll explain to you what it means. In Excel, you were learning how to analyze data, right? Speak to me. Respond to me,
Yeah, I'm
please.
listening to you, sir. I'm listening to you.
You were learning how to analyze data that you already have.
Okay.
SQL, the data is seated somewhere. You want to know how to retrieve it so that you can analyze it. Do you
Okay.
understand the difference?
Okay, sir.
You understand the difference?
Yeah, yeah.
All right. So what you did in Excel was to retrieve data, format it, and create visualization. But here, you cannot do that, right? You're only querying the data. Okay. When you learn SQL and you're now learning Power BI, you now learn how to connect this SQL to Excel, Power BI, in order for you to analyze it and bring information and vital information for the company. But don't worry, to connect the dots will connect in your mind shortly. Okay.
Okay.
So let's move on. So these are the types of join that exist. How many of you remember this image? Anybody who's going to talk? You can unmute yourself. You guys should interact, please. You can unmute yourself and interact. How many of you remember this image?
Yes, I can remember in maths.
Good. So what does this mean to you? Forget about what is written here. What does this mean to you? Can anybody remember?
Okay, the first
Yeah,
table, B, the center is called intersection. That means where table A and table B meet.
Okay. What of
Yes.
this?
So the second one, same thing. It's just that, okay, the bolded side for table A is just talking about um some intersection with B and the whole of table A.
Good, good, good. Exactly. This is also exactly as this. This and this are the same, but the only difference is where the table is, right?
Yes, sir.
And this means everything but the intercept. All right, so these are the types of joins. They are inner join, left join, right join, and full join. Okay. Everything in the intercepts, left join, right join, and so on. So I will not, because we need to close now. The class is supposed to end at 4:30. I will just do one example, which is the inner join with something that you're already familiar with, and then we'll continue from here. So this is the first join called the inner join. What happens? The inner join select records that have matching value in both tables. Just like you have said. Matching rows based on attributes supplied in the predicates. Inner join is the same as join. The keyword inner is optional. So we're going to do one example so that you guys can see. I'll just do this example so you guys can see. But just hold on. Let me open an Excel sheet. Let me explain to you what an inner join is first. While my Excel opens, okay. So let's imagine that this is table one. Please listen to this very carefully. This might unlock your understanding very well. Let's call this table A, and let's call this table B. Now, table A is ID, or you guys usually have matric number. You have name, right? Right? Let's say matric number is 1, 2, 3, 5, no, 4, 5, 6, and let's say 10. Mary, Tony, James, Antonia, and Philip. All right, so let's imagine that these are students in the university, and they wrote an exam, and the result is out. Okay, so let's put matric number. One, 4, 6, and 146. And we then put scores. And we then put let's say put the course or the scores that they got in the exam. So somebody got 20, or 60, 70, and let's say 2. And this person scored 40. Okay. So I want to ask you guys the question. So these are the two tables. So let's imagine these as the two tables. Okay. A, B. Good. Now, if I want to ask you what is if I want to get the scores of people who wrote this exam, so this is the department, all right? And this is the exam, they wrote a mathematics exam. So if I want to know, if I want to get the scores of people who wrote this exam, what I would do actually, I want to know the name and their score. For me to know that, I need these two tables. I need the math number. So look at how I'm going to do it manually, and the scores. Good. Now, let's see how that result will come. How it will work will be 1, his name is Ben, and 1 meets with 1, and we can now write matric number 1, his name is Ben, and score is 20. What else can we do? Number 2, although it's in this department, he didn't write the math test, so his name will not appear. Oh, number 2 and number 2, Mary. So we can write number 2, Mary. We have 40. Number 3 does not appear here, so there's no relationship. Number 4 appears here, and number 4 appears here. So we put 4, James, 60. Number 5 appears here, number 5 doesn't appear here, number 6 appears here. So we have 6, Philip, and 40. Right, so do you guys agree with this? That this is the exact reflection? Do you agree with this?
Yes, yes, sir.
Okay. So what we have just done, so let me explain to you.
I noticed something here, sir.
It's 70 for
Philip
Philip.
is 70, not 40.
Oh, sorry, that's my mistake. Yeah, good. Good. So you guys agree with me here. So let me explain to you what has happened. You know, everybody can be in a department, right? I just want to explain it so that you guys can relate with it, because you guys have, most of you have either finished university or you're undergraduates. So let me explain it so you can understand. You know, everybody can be in a department, but some people are not writing some courses, let's say, because it's an elective course or they don't need it, so they're not writing. So if, for example, an exam, everybody's in a department, let's say Department of Chemistry, and they need to write a math course. Some want to write, some might not want to write. So if I'm asking you, so this is like the master sheet where everybody in the department records are kept. But right in that department, only 4 people wrote that exam. If you want to bring out the result of those 4 people, you really cannot add the people who did not write, because I'm only asking for those people who wrote the exams. This is exactly what an inner join is. The first join that I want to explain here. This is what it means. It means this is table A. I just want to explain it in Venn diagram terms so that you guys can understand. This is 1. This is 2. This is 4. This is 6. And this is 3. And this is 5. And this is... So do you guys agree with this?
Excuse me, sir.
Do you guys agree with
Yes,
this?
sir.
So the result of this particular question is everything that is here. Do you agree?
Yes, yes, yes.
That
Yes,
the result is everything that is here.
Yes, sir.
Good. 1, 2, 3, 4 is the interception. That explains this. Does it not explain this? That the result of an inner join will bring what is common between the two of them. Do you guys all agree?
Excuse me, sir.
Go on.
Yes, sir.
I was thinking maybe it's supposed to be a right join rather than inner join.
No, no, no. I did a right join.
Because the whole value of table B is intercepted.
No, the result is the
Yeah.
intercept. 3 and 5 did not write the exam. Why do you want to put them here? This is the result. I've shown you the results when you want to match it with your eyes. 1 wrote the exam, you put their name. 2 wrote the exam. 4 and 4 here. 6 and 6 here. This is the result. Okay.
In the remaining part of table B, what will be in that Venn diagram?
Nothing.
Okay.
Now there are situations. So let me explain to you. If there was a number here like 10, let's say this person wrote from another department of physics. He wrote the maths exam. Okay, and the person got 70. Okay, but the person is not. This person's math number is not in chemistry department because he's not a student of chemistry. But he wrote from another department to write the maths exam. If you want to write that, then this will have 10. But it will not appear in the result. Because what you're looking for is what is common between these two tables.
Yeah. Okay.
Do you understand now?
Yes, sir.
Good.
Thank you.
Good. But in our example here, what the result will look like is this. Everything in the center. All right. Now, since we've seen this we use a manual way of looking at it, and we have also joined things together using the Venn diagram. So it's easy for us to understand this concept, that the language for bringing tables together is called, for bringing tables together where you're looking for the commonality between the two tables, is called an inner join. There are many other joins we're going to learn, but let's do only the inner join today and we'll be right. So I want to use a real example to explain to you. Good. Let's use this data. This is the only example I'm going to use. So let me ask you guys, how many records? So this business have some people in the human resources department. How many records do we have? from the human resources department? Hello? How many records?
290.
290. For those who don't know how he got that, I'm putting 2- here because I want to make a comment. So I have 290. So you could see 290 rows. Okay. So what you are saying, please listen to this very carefully. So what this means is that we have 290 staff. You remember that I told you that this particular human resources, this particular database dictionary, the human resources employee, shows information about employee information such as salaries and title and many other things. And it is clear to us that this particular business has 290 staffs and they have a unique identification from number 1 to 290. Good. Now, I want to ask a question. Um, query the name, the first name and last name of all staff. So query the first name, query the business entity ID, gender, marital status, hire dates, first name, last name of all staff. So what does this bring to your mind? So what is he asking me? So what does this bring to your mind?
He's asking us to select specific.
Please, you guys should unmute yourself and speak, please. What does that question bring to your mind?
The particular
Okay, according to my own knowledge, it wants us to connect different schema. For instance, now first name and last name, that's schema for person. Business entity ID. Okay, we know that one is mostly common with all the schemas. Gender, marital status. I think that one we can see it in human resources under the employee ID.
Good. So what this means is that listen to the rule and follow the rule as you are learning. If a question is asked to you, the first thing is to ask yourself, which schema and table, to know the schema and table. Based on this question, you know that from your practice so far, you know that gender comes from the human resources table. Marital status comes from the human resources table. Hire date comes from the human resources table. But first name and last name come from the table called person.person. So we already, I'm sure that the tables we are interested in to solve this problem is HRO and person.person. Do you all understand this now?
Yes, sir.
Yes, sir.
Yes, yes.
Yes, sir. Yes, sir.
Now we know this, so I want to query the first part. Please listen to this explanation very well. I just want to do some exploration first before we really do the query. You all have agreed with me that we have 290 staff, right? Do you all agree?
Yes.
Yes, sir.
Good. So
Yes.
let's also look at what is in the person to be sure whether that's where what we need is there. So I'm using asterisks for now because I'm just exploring. So how many names of people on this database? How many on this person?
19,000,
19,972.
19,972.
Okay. All right.
Yeah, go.
Okay, so this is what is happening. Look at what is happening here. Let's look at it carefully. This is the human resources table. This is the person.person table. Please, if somebody is speaking, unmute yourself. And speak. Do you guys agree that this is what we saw when we queried them just now? When we queried the person, human resources of the employee, we got 290 from number 1 to 290. Do you guys agree?
Yeah.
Yes, sir.
Can you hear me?
Yes, yes, yes,
Yes,
yes.
sir.
Do you agree that this is 1 to 290, the human resources of the employee?
Yes, sir.
Yes,
Yes,
sir.
sir.
Do you agree that in the person, you had 1 to, let's say, 290, 1 to 19,000, right?
Yeah, 19,000
Yes,
and
sir.
something. Yeah.
972. Yes, sir.
Good. Okay, so so do you agree that every member so the person.person, so let me tell you about the person.person first. The person.person contains, let's see what the person.person means first, so I can explain it to you. The person.person contains information about what? Somebody read it for me. Somebody read it out.
Business identity ID.
No, read
Person
this,
type.
read this, read this.
Human
What's
beings.
that?
Human beings involved in adventure work,
Okay.
employees, customer contacts, and vendors contacts.
Okay, how many employees do we have?
We have
200
290 employees.
Good. So what this means is that the person.person contains names of employees, contains names also of customers, and contains name of vendor. So it's a combination of 3 different names identification. It contains employee, customers, and vendors. That is why it is so much, up to 19,000. So do you all agree that this 290 is inside of this 290?
Yes, sir.
Yes, sir.
Yes.
And there are other extras that are not customers. They're not employees. Okay,
Yes,
Yeah,
sir.
yeah.
Yes,
Yes,
sir.
sir.
good, good. So what this means is that if somebody asks me a question, I want to answer the question. I don't want to answer anything extra. He's asking for only this information. He didn't ask me for vendor or employee. So there are 290 here, there's 19,000 here. This 290, there's a relationship between the first 290 in this 19,000 are people from human resources. So if you really check it clearly, you see the first 290 here are human resources. See that? Okay. You even see the tag SP, SPP. It means salesperson, salesperson. These ones are from here on are not staffs of the business, but they're all in one table. So with this, can somebody tell me that this is correct? Look at this. That if I do an inner join and I want to only get employees, that I'll only get 1, 2, 3, 290. Does everybody agree with me? If I do an inner join, I'll get what is common between the two of them. And it's the first 290. Do you agree?
Yes, sir.
Yes,
Yes,
sir.
sir.
Good. So with this example, it is clear that we'll only get the 290 if we use the inner join because it's only asking for the things that are common between the two of them. So let's write our first query and we'll round up with this. So to write that query, it is called select from the first table the second table, you inner join it on the basis for their join. So let me explain to you the basis of their join. So now let's go to human resources employee. I want you guys to understand this. I'll stop here. So let's go and see human resources employee. You remember that the human resources employee are the two tables we want to join because the question leads us there that we need human resources and person. So the first thing I want to check is the information. I know that this is the primary key because of this key symbol, business entity ID. Now, sometimes the table will show you the other tables it is linked to and the basis of the relationship. So, human resources to the employee is here, but if you look at the dictionary very well, it will tell you the other table that it is linked to. You know, we need person. So because human resources and so the dictionary is showing us that there's a relationship between human resources and person. Okay? It's a relationship between human resources and person. And what is the relationship between them is that they are related through
Number of
human
employee.
resources business entity ID, which is the primary key here. So what the dictionary is showing you here is that the relationship between these two are on the basis of, so you could see, showing you that this is person, that human resources and employee is related to the person based on human resources.employee business entity ID is equal to person.person dot business entity ID. So it's showing you the base of the relationship is business entity ID and business entity ID. So because of that, we now know what is the primary key and the foreign key. This is the description that shows us the basis of their join. Based on, so this part is the name of the table. This part is the key or the column. This part is the name of the table. And this is a, so let's write one so that you guys can see a clear example. Now, follow me carefully. This will be the last thing we'll do. Okay. So since we now know the two tables we need, so we now can I write the query following this instruction. Select the columns. Now look at this carefully. We need the business entity ID, we need the gender, we need the marital status. Now look at this carefully. Select from the first table we need is the human resources.employee. But I'll give it a name. You remember alias. Call it HR. You guys remember that? How to give something a name. Alias.
Yes, sir.
Yes, sir.
Great.
Yes, sir.
Now, the reason I'm giving it a name is so that when I'm writing it, I want to use it. I don't need to write the human resources in full. Just give me a moment. My mouse is malfunctioning. Right? So I don't need to write it full. So I give it a name. I'll write inner join because I want to inner join it with person.person. Give it a name as PP. Now, the reason I'm also giving it a name is so that there will be no conflict. Because, of course, you see that the human resources and the person.person, they both have business entity ID. So if I go and write business entity ID here, if I go, because I want to query something specific, if I go put this here, it's going to be giving me an error because the both tables have business entity ID. So I must indicate where do I want it from. All right, because both of them are in conflict. So with the alias that we have done, I can write HRO dot. So I'm now very specific. Okay, what else do I need? I put a comma. I write HRO dot. I need, the question says we should get what? Gender. HRO dot hire dates. What other thing they asked? Marital status. Then I also need first name. So the only place to get the first name is to use PP dot first name. To get the last name, PP dot last name. Good. Now, I've done the first few parts, which is select the columns of interest, which we have done from table 1, which is the human resources table. What table do you want to interjoin it with? Interjoin it with table 2, which is person of person. But you must show it on what basis you want to join them together. On what basis is actually these that I showed you earlier. On the basis of human resources.employee ID and person.employee ID. So we can write that quickly and say on HRO, because I've already given that name, HRO, it's always going to appear that I've already given an alias here, so it recognizes it, equal to pp dot so I've completed the task. I've said join human resources and this together. Remember, this has 290 records. Remember that these have over 19K. I want to join them together. Good. On the basis of human resources business entity ID, the primary key to this other foreign key to create the relationship for it to produce a result. Actually, this is what we are trying to do. This is a key joining to this key. That on pp.this equals to hr.this is what this relationship looks like. So can anybody tell me the result the number of records we are expected to get from this?
90 rows.
How many records are we supposed to get?
90.
290 rows.
Huh?
290 rows.
290.
Yes, exactly. So because the relationship the reason we are getting 290 is because that we are looking for what is common between the two of them, which is 290 records, the number of staffs, 19K in the person that contains employee, vendors, and customers. But we're looking for only employees. And if we click on the query and we execute, we'll see that we are exactly getting now 290. And you could see the BNTT ID, the gender, marital status, first name, and last name. So we have seen a clear example where we relate one table to another to produce a lot more, a robust answer to the question. All right, so I'll be wrapping it up here. I'll be waiting for questions. We'll take another session to round up this. So I'll be waiting for questions. Any question?
There's a question, sir.
Yeah, go on.
The question is, if I just input join,